Okay, so in the last problem from the homework that was due today on 7.3, you had a function that was a piecewise function that was a certain, like, say, type of signal. Signals have different representations, and in the problem you had, I believe your signal, well, it had just a function that looked something like this. But how many maybe have seen in a class a signal that has this kind of form? Maybe in a class they've had or taking now, or have seen, like, if you've taken a class on signals. Okay, Kathia, that is familiar for her. And so, okay, so, and Christopher also as well. And Andre in physics, excellent, excellent. It's important to be able to take, okay, Matthew, yeah, well, sure, they come in a variety of ways, a variety of representations, a variety of applications. But the problem you had, you were presented with a function like this, and you were asked to find the Laplace transform of that function. So of course you have to come up with the function. You know, what function, and you know the unit step function is going to be involved in finding finding what function represents this piecewise function. So I wanted to do an example where we're given a function and we have to write it in terms of this unit step function. I think that'll help you feel a little more comfortable with this kind of thing. All right. So what we want to do, we have a piecewise function here. F of t is equal to 1 when t is greater than or equal to 0, less than 1. And then f of t equals -1 when t is greater than or equal to 1. So let's say you had a differential equation where the driving force, the right-hand side, was equal to this function f of t. So what you'd have to do is you have to write the function in terms of the unit step function in order to then eventually be able to take the Laplace transform of this function. Okay, so what would be helpful first to have regarding this function? What might be a first step in this problem, in solving this problem? What might be a first step?
Well, I think recognizing the a value, which will be 1.
Okay, Michael, certainly. That we know that's important. And also, let me give you a little hint here. Let's make a what of this function? Let's make
a graph.
Yeah, a graph. Good. Okay, so I'm going to do that. I'm going to do that on the next page. Here's a graph of this piecewise function. There it is. So I'm thinking about you in homework. I'm thinking about you, on the final exam. Maybe you have a problem, something like this, where you have to write the function in terms of the unit step function. So first thing you want to do, you don't want to, you want to make your life easy. So draw a graph. Draw a graph of that piecewise function. Let's see. let's see. Does someone have their mic on?
Yes, that was me.
Oh, okay. Okay, Michael. You could probably mute. I mean, you could probably mute yourself for the moment, but I mean, but then unmute when you want to respond, of course, because we want your input. We want your input here. All right, excellent. So, no problem, Michael, no problem. We're this is you know, I've tried to make this class very. I mean, we're not in the in the physical classroom setting on campus, but I've tried to make it as close to a classroom setting as I can. For remote learning, in terms of people asking questions and so forth. So okay, so here is the unit step function. Okay, here's the unit step function at t minus 1. Now, that function, okay, if I were to draw it, and I can actually, I guess, draw it here. Okay, that function. Okay, so it's going to equal 0. Okay, and then when you reach 1, the function jumps up to 1. And what I like to do also is I like to put, like it includes 0, so I'm going to put a solid dot there. And then at 1, there's a hole there. Okay. But then it, includes that 1 there. So this is an example of the unit step function, but that does not resemble at all my function that I need to find, right? I mean, or find, express. So, for instance, this particular, and this is t here, right? This particular unit step function, okay, and it's really just the definition, right? It starts at 0, and then when time reaches 1, the function jumps up to 1. Well, my graph does kind of the opposite. My function at time equals 0 starts at 1, and then at t equals 1, it drops down to -1. But I'd like to I'd like to flip this unit step function, and that's what I do by taking 1 minus the unit step function at t minus 1. Okay, 1 minus the step function at t minus 1. And so that would give me this function here. 1 minus the unit step function t minus 1 will equal 1 when t is greater than or equal to 0 and less than 1, and it will equal 0 when t is greater than or equal to 1. Okay, so are we okay based on this? Then this has to be true. Are we okay with that? Good. Thank you, Matthew. And you notice the picture here, it's looking a little closer to my function f of t. Okay, it's looking a little bit closer. Okay, but we're still not quite there yet. Oh, Mark, how am I changing the piecewise function? Well, what I'm doing is so like for instance, Okay, hang on. Okay, all right, I can show this. I can show this. So how am I getting the 1 here? How am I getting this 1 here? Well, that comes from 1 minus 0. Okay, let me write it again here. How am I getting this 1? That comes from 1 minus 0. Okay, this 0 here. And then how am I getting 0 down here? That comes from 1 minus 1. That one there. Well, so Mark, I'm like this piecewise function here. I'm trying to come up with the function f of t in terms of the unit step function. I'm not there yet, but I'm a little bit closer. You know, at this stage, I got this behavior nailed down at this stage, but we're not there yet. You're right. You're right. So what I say to myself is, okay, well, what if I were to, you know, what about this? What about this part? What about this here? How can I get something that looks like that? Well, what if I were to take the unit step function and multiply it by -1? If I did that, then I would have 0 when t is between 0 and 1, and -1 when t is greater than or equal to 1. And that gets me this function. So that kind of gets me this behavior here below. So the idea is this. What if I were to think of it like this? Think of it like this. What if I were to, I want to, hold on here. What if I were to take this function here, I'll call it function 1, and if I were to add to function 1 this function 2. If I added 1 plus 2, would that give me my f of t function above? Is my f of t function the same as adding those two stepwise functions? Well, let's think about that. It actually will, Matthew. It will give us that. Think of it like this, and I appreciate. So I like people. I like people that doubt. That's good to doubt. So now I got to prove to Matthew and to everybody why this works. So think about the 1. Yeah, we're adding based on the graphs. That's what I mean. Yeah. That's what I said. Based on the graphs, if we add these two graphs, 1 and 2, wouldn't that give us the graph of this function up here? Well, that's what I meant. That's what I meant. Thank you, Matthew. That's what I meant. If I add graphs 1 and 2, wouldn't that give me the graph on the top, which represents my function? I mean, think of it. Well, all right, think of it like this. Okay, okay, watch this, watch this. Okay, watch this. So we're going to add this function here. Let me put it in blue. So we're going to add this function here, 1 minus the unit step function, to -1 times the unit step function. That means when t is between 0 and 1, we're adding 1 and 0. What's 1 plus 0 equal to? 1. Okay, for when t is between 0 and 1. So that matches this here. That matches. Okay, now let's look at when t is greater than 1. Okay, when t is greater than 1, I'm adding 0 and -1. 0 and -1 make -1. That's right, Matthew. You add them together. When you add these two functions together, it gives you one function. And that function will be equal to the function that you want, f of t, that f of t function. And so f of t is going to equal, yeah, that's right, add them piecewise. That's right, since they're piecewise, you add them piecewise. And naturally, the breaks, you know, have to match with both functions. You know, t is between 0 and 1, t is greater than or equal 1. So now we have 1 minus the unit step function plus -1 times the unit step function. And so the final answer then, our f of t function that's going to equal the piecewise function is going to be 1 minus 2 times the unit step function at t minus 1. Excellent, excellent, excellent. Matthew's comfortable. Who's reasonably comfortable? Kathy is excellent. Antonio and Christopher, wonderful, wonderful. So now, what would we do here then? You know, what would we do? Okay, if I go, so again, you know, if you can express the piecewise function this way, then when you take, you know how to take the Laplace transform of a unit step function, and you know how to take the Laplace transform of the number 1. So it allows you to take Laplace transform, a Laplace transform of a function that is piecewise. The trick is, though, before you can even begin the problem, you have to be able to take this, whatever piecewise function you're given, you know, you have to be able to take it and express it in terms of the unit step functions. Okay, and there's an example in the book, figures 7.3.3 and figures 7.3.4. This is in section 7.3, where they give a few more examples. But I thought, I mean, now you have a lot of good examples. I don't want you to miss a problem on the final exam because you can't write your driving function, you know, your driving force function in terms of unit step functions. You know, I want you to do well on the final exam, right? I want you to do well. And incidentally, I do have your exams graded, and I will be providing updates on your grades and so forth just a little later here. But are there any questions before we move on? Okay, excellent, excellent. Matthew's good. All right, I'll stop the recording.